Oh, one dimension. So okay, okay, got it.
One motion in straight line means just we're talking about object which is moving in a straight line.
Yes.
So when it is in straight line, that means distance and displacement will be same, will be equal, and speed and velocity will be equal. Distance and displacement are same, that means speed and velocity are the same. Now, distance is vector or scalar quantity?
Scalar.
Scalar quantity. What about displacement?
It's a vector.
Vector quantity. So because of that, speed also scalar and vector, velocity also vector.
Yes.
Okay, fine. This is actually motion straight line. Since last 2-3 years, there are no questions from this topic. So that might be possibility this year you will get. Particularly this topic. I'm not talking about all the motion topics, particularly straight line topic. So in this topic, we'll discuss about speed, velocity, acceleration, and all that form of motions. Uniform motion, non-uniform motion. Now, first of all, what is motion? Yeah, what's motion? What happened, guys?
When an object is moved from the rest position either by force.
Okay. Yeah.
So if the position of an object changes with time, then it's in motion.
Yeah. That's true. Okay. So motion means fine. Okay. So movement of object. In simple terms, motion is movement of object. So there are like simple two types of motion: uniform and non-uniform motion. Okay. When can we say that object is in uniform motion?
So when the, it's in uniform motion when the acceleration or the velocity is constant.
How can you say that velocity is constant?
Well, okay, not velocity.
Then when can you say that object is in uniform motion? Aditi, are you connected?
Sir?
Yeah.
If it covers, equal distance in equal time.
Okay, equal distance is equal time.
or
Okay.
if the graph is linear.
Okay, what kind of graph is linear?
Velocity time, I'm not sure. Displacement time, this I don't know about the graph.
Okay, saying some graph is linear. Okay.
The graph of motion, maybe. I'm not sure.
Yeah, it's okay. It's okay. Somewhat you know, right? Very good. Yeah, Garima, what do you think when which object is in uniform motion? When can we say that object is in uniform motion?
When an object changes its position at regular intervals of time.
Yeah, regular interval of time. An object change its position equal, like it's not like just it's changing any random position. It's changing equal position.
Yes.
Okay, Shadam.
Thank you.
Okay. So when can you say object is in uniform motion? When, as you all said, correct? Equal distance travel in of time. Okay. See, when we are saying equal distance travel in equal interval of time, let it be smallest or biggest. It doesn't matter. That is not our point. Our point is it's traveling equal distance in equal time. Let it be so small value or so big value. That is not our concern. Okay, so when can we say this object is in non-uniform motion? Yes, anyone? Anyone can answer? Come on. Ayush?
Yes, sir.
Yeah, when can we say this object is in non-uniform motion?
So I don't know. I just joined the class.
So it's okay. Like whatever you know, have idea, you can tell.
Somewhat movement.
See,
Sir,
uniform, yeah,
uniform is sir, not a constant speed. Sir. It's change speed.
changing
Sir, equal distance traveled in unequal time of interval. Like that.
like that. Okay, fine. Okay, Samhita, what do you think? What will be the non-uniform motion? Someone wrote answer. Wait. Okay, yeah, that's true, Aditi. Right? Okay, Shamita.
Yes, sir.
Yeah, what do you think? What will be non-uniform motion?
Okay, I just say it or type. Sir, I think non-uniform motion is when an object travels equal distances on unequal time intervals, or an object travels unequal distances or in equal time intervals.
Either way.
Yes.
Yeah, either one should be non-equal. Yes, good. So similar way, or speed or direction or both changes with respect to time. Or other way you can say unequal distance in equal interval of time. That is non-uniform motion. So these two were the types of motion. There are other types also like rectilinear, curvilinear, rotatory motion. For that we have one separate chapter. I'm just giving highlight of this chapter. Okay. Then in this motion, we should know about distance and displacement. What is distance? What do you mean by distance? Kirtana,
The actual path traveled, sir.
the actual path traveled. Actual path travel, length of path travel, or final and initial position. Now, what will be displacement?
Sir, the shortest part between final and initial point.
Exactly, shortest path. Okay, so distance can be 0. Initial and final point. Yes, Aditya.
No, sir.
Can I say I travel 0 meters?
No, sir.
Cannot be, right? Okay. So distance cannot be 0. Can distance be negative?
No.
No, sir.
No, right? So distance will always be positive. So it's a scalar quantity. Displacement, can it be 0?
Yes, sir.
Yes, sir.
Can it be negative?
Yes, sir.
Yes, sir.
Then obviously it will be positive, right?
Yes, sir.
So this all three possibilities for displacement. So it is a vector quantity. Okay. Now for this we need to know what is speed. What is speed?
Sir, distance over time. Distance
Distance
covered
by
in a certain time.
time taken. Distance traveled by time taken. Then velocity.
The displacement by time.
Yes. Displacement by time.
Sir, can you scroll up a bit?
Now, tell me all these units for this people. Distance unit, SI units,
Meters.
Meter.
Meter.
meter, displacement SI unit,
Meter.
meter. Then speed,
Second.
second,
Meter per
Sorry,
second.
meters per second. I thought you said time. Meters.
meter per second. And displacement,
Meters.
meters.
Displacement, right? It's a length, so it's meters.
Okay, and time,
Second.
Second.
so speed, velocity has same dimensions, distance, displacement are same dimensions and unit, right? So what can we conclude here from the topic? That this, when the motion is in straight line, distance and displacement will be same. Not necessary it will be like same in all the cases, but if we are talking about one point to another point which is moving in a straight line only, so from first point to last point, these are same. Same goes with speed. Speed will be same as velocity. They both will be equal. Then what is the actual difference between speed and velocity?
Sir, one has direction, one does not have direction.
Yeah. So in short, what is velocity? It's a change of position. Rate of change of position. When we say change of position, that is displacement. Rate of change of position means displacement by time. So there is only small difference, that is change of position. At what rate position is changed, that is velocity. So in that we'll study what average velocity. What is average velocity? Okay, let's talk about average speed.
The total distance by total time taken.
Same goes with average velocity, right? Average
Yes.
velocity means total displacement by total time. Now, instantaneous. What do you mean by instantaneous?
Sir, at a specific time, what would be the velocity?
Exactly, at particular time, at a given time, at this instant, whatever speed it is, but at this instant, what is the speed or velocity? Okay. Now, your speedometer, you know speedometer, right?
Yes.
Where have you seen this? Where we will find this speedometer?
On cars and bikes.
Yeah, on your vehicles. So that shows average velocity or instantaneous velocity, or average speed or instantaneous speed. What does it shows? What it shows? Aditi, you can type your answer. Yeah. Ayush, what do you think?
Yes, sir. So repeat this question.
Okay. I'm asking a speedometer. It shows what type of speed? Average, instantaneous, average velocity, instantaneous velocity.
Yes, sir. Instantaneous.
Okay. What do you think, Kirtana?
Yes, sir, instantaneous.
Instantaneous. Okay. Samhita?
Sir, I also think it's instantaneous.
Yes, that's true. It shows instantaneous because whenever we are looking at it's change every instant. After we press our accelerator, after we accelerate those things, your pedal, it will change speed. That means it is instant. It's showing some other values. It's instantly changing values. That is instantaneous velocity or speed. Now, if I want something like acceleration, as we came to know, like what is acceleration?
Sir, the rate of change of velocity.
Yeah, rate of change of velocity. So remember, whenever this rate comes, it means it is divided by time. Now, just now I said change in position. What does it mean? Change in position.
Displacement.
Displacement. Rate of change of position.
Velocity.
Velocity. Okay. See, sometimes in your exam, they will not like directly give things like this is the displacement or something. They will just mention, okay, change in position of an object is this one. That means that is displacement. One second, please. You finished writing? Done?
Yes, sir.
In this one, we will derive like those kinematics equation. Do you remember?
Yes, sir. V is equal to U plus AT, and C is equal to
Yeah.
UT plus half AT.
S equals to UT plus half
Half
AT
AT
square, and V square equals to U square plus 2AS.
U squared plus 2AS.
These are normal expressions, normal equations. Then when we go to third one, what is this? Okay, when we go with the one next topic, next chapter, these equations will deal with your height also. That means this acceleration will change to gravitational acceleration. So their formula
in
will
free
be,
fall, right?
yeah, in free fall. U plus GT, then H equals to UT plus or minus half GT square, same plus minus. V square equals to U square plus or minus 2GH. This whole formula will change. We'll derive all these formulas. And main thing from this chapter is graph. That is most important part. You need to understand graph, how to read graph, how to understand this graph. Okay. So this is what our highlight of this chapter. In this one, like same thing, we'll just match up like what is uniform velocity, uniform acceleration, and non-uniform acceleration, free fall, all these blah 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 things we'll study. Yeah, by the way, what's the that units for this one? A
Meters
equals,
per second square.
yeah, how we got meter per? Because it's change of velocity. Change of velocity with respect to time. So meter per second by second, which is meter per second square. Okay. So let's go with some basic part here. I give a small highlight of this one. Yeah. This as I started this chapter, start topic, this one I said, this all you will study in your mechanics. I think so. Just you were there, right? Siddharth?
Yes, sir.
I don't know. Only you were there, right? I was talking about mechanics.
No, sir.
So, okay. Okay. So it's a mechanic. This is what you're going to study, mechanics. It's what? A branch of physics, where we'll study what? Object in rest and in motion. So rest means static. Static mechanics. So study of, this all a study of physics or branch of physics, study of object deals with this one. At rest. Study of object at rest. Or other way, see, if we are saying object is at rest, means what is the other way we can say? Like they are in equilibrium.
Yes, sir.
They are in equilibrium position. Kinematics. Now, see, object is rest and motion. In that also some parts are there. Like object, something we will say, okay, object is moving. We will not consider that. What is, why it is moving? Next, we will study object is moving, why? Like we have separated those topics. Like that we'll study in NLM, Newton's law of motion, why it is moving. Here we'll study object is moving. How it is moving, what causes we will not see in kinematics. Motion of object without considering cause of motion. Where we study dynamics, that object is now motion, but why it is? Why it is in motion? It is cause. Motion of object with considering cause of motion. This everything comes under mechanics. Then when it is moving with some other way, like heat and all that, that will study in thermodynamics. And last part we'll study like oscillation of the object, how it oscillates. With pendulum, simple pendulum, all that.
So is that all of physics? I mean,
Yeah.
that we have. Okay.
Here in 11th standard, you will totally discussing about object, how it is moving,
Yes.
not particle. 12th standard, you will totally study about particles, particle motion, particle moving, particle study. Particle in the sense electrons, protons, smallest particles, atoms, and all that.
Yes, sir.
Till 11th, you studied everything, actually, everything you have studied. But overall, you got idea, okay, this is what it is. 11th standard, you'll just study about object. Then you'll go in detail, that is in 12th standard, that is particle. Nothing big. Same thing you will study, but different way. And last topic is after 12th standard, that is modern physics, which is very, very important for your JEE and NEET exams.
So what does it cover?
It covers all like atoms and whatever we have found new things now, like atoms and nuclei and semiconductors, all that.
Okay.
That is nature of these particles. This we consider as modern physics. Actually, it's not modern. It's we found this ages back. But in modern physics, it should include some other quantities. But okay, whatever. Actually, 12th standard subjects are not that much important for your colleges. I didn't find any subject related to 12th standard. Small topic will be there, like generator, AC and all that. Basic electronics, like semiconductor, what you study, fine. Second part is there. But much more subjects are from 11th standard. Okay. Then this writing
Scroll up.
up. Okay. This part?
Yes, sir.
Achha.
Okay, so that's enough. Fine.
No, you can write it. It's okay. I'll wait.
No, sir, I wrote it down. I'm just checking if I missed anything.
Achha, okay. Everyone done writing? Anything you left? Actually, these things is not like if you don't write, then also okay. Anyhow, this is just highlight of the chapter only. We will study this same thing again in detail. I was just making you mentally sure, prepare like, okay, this is all things we are going to move around. See, whenever, not now, any subjects, when you start any topic, just go through first. Okay, what are topics I'm going to cover? That will create your interest. Okay, this is I will study. This I will study. This I will learn. It will create your interest. Okay, yeah. So I'll just go through full chapter, just not reading part. Just see. Okay, topic names. Okay, this is okay. This one. That's actually my habit. You can create your own whatever way you want. Okay. Now rest. Object as rest. Let's study about rest. When you can say object is at rest?
So when it's not in motion?
It's not in motion. Okay. That means if we be a little bit specific, then it is not changing its position.
Not changing its position with respect to time.
Exactly. So rest means object is in, like it does not move, or specific if we say like it is not changing its position in the sense with respect to time. Object is, you can write it in your own words. Position with time. Now, again, there's one more question in this one. It is not changing its position with respect to time. So I'm sitting in the train. I'm at rest position with respect to what?
With respect to, your surrounding, we need a reference point for that.
That's what main thing is reference point. Here we need to know what is reference point. What is reference point, first of all?
It's the the reference you take in order to determine if something is at rest or not. You compare and you see.
Something I need to compare. Not just for position. If I say reference point, means it's a point or a thing like I'll compare with other thing. So that is our basic quantity, reference point. Now, as I gave you example, I'm sitting in the train. I am at rest position with respect to what? With respect to train, a person who is sitting next to me, or the person who is standing on the platform.
The person next to you.
Exactly. But it will be not, I'm in rest position for next to you or with respect to train. Train is moving, I'm not moving. But as per the person who is standing outside of train and I'm crossing by him, I'm just passing through like from the railway station, is standing there on platform. If you watch us, what do you think? That object is moving. With respect to him, he is standing on the floor. He is steady position. The ground for him is the reference point. For us, the train is the reference point. So it depends upon, everything depends upon reference point. With respect to reference point. With respect to a reference point. Okay. For this chapter, numerically, we will consider this as an origin. Origin as a reference point. We will not fix it. Depends upon question. They didn't give anything. That means we will consider that origin. If they give some reference point, then okay. Okay. Object is in motion. When can you say this is object is in motion?
When its position changes with respect to
Time. Okay. Same way, right? Object is said to be in motion if it changes its position with respect to reference point or surrounding. So here reference point is important. Okay? Everyone,
yes, sir.
are you listening, right?
Yes, sir.
Guys, are you connected? Some
Yes.
Yes, sir.
okay. So this is online class, okay? Like keep reporting, yeah, I'm there. Otherwise, I'll think I'm just talking to myself. And then I'll feel bored. Okay, I'm talking to myself or what? See, you can try one day. Some like whenever you are getting bored, now talk like switch on your Zoom meeting and talk to yourself. In 2 minutes you'll get bored. Not even 2 minutes. Okay. Point mass. Okay, by this word, what do you think? What comes in your mind? Point mass. What do you think?
When I think about it, center of mass comes to my mind. A point that the mass can be, concentrated into.
Okay. Okay. What about others? What do you think of this word? Like point mass, point object, whatever. What comes in your mind? Ayush?
Yes, sir.
What do you think? What it will be? Point object or point mass?
The point objective.
Whatever comes in your mind. Tell me. A very small object. Okay. An object represent the point to make calculation. Okay. Fine. Others? Garima, what do you think?
No idea, sir.
Just okay. I'm just asking, like, what it comes in your mind when you read this word, point object? It's not necessarily that it should be right or wrong. Nothing is right or wrong. Samita, what do you think? What it will be?
Sir, maybe an object at a specific point. I see.
Object at a specific point. Okay. What about Kirtana?
Don't know, sir.
No idea. Okay. Okay. Now, let me give a small writing here first. Object is said to be point mass if, see, as you said, I'm just mixing all those terms. You wrote a very small object representing calculation. Yes. Whatever you said, it's correct. So I'm just mixing those words. During its motion, it covers distance much greater. So if this is a small object, it will cover greater distance as per its size, more than its size. It could, more than it could. Can you think of any example of this for this?
Sir, a bus.
Sorry?
Sir, a bus.
Actually,
Like
bus is the bigger object. Yeah.
Bus.
Okay, as you're comparing that way, yeah, it might be correct. See, if you think, yeah, you fill the petrol, we can move further, faster, like more distance, much distance.
Sir,
Yeah.
how about an electron that that jumps out of its orbitals because it gets excited?
Yeah. When we get excited more.
Yes.
Yeah. That is a point object, a small object. Okay. So an object which is small and covers much more distance than its size. It is called point object. Next is one-dimensional motion. What do you mean by one-dimensional motion?
Motion in a straight line for 1D.
Motion straight line.
So only in one axis.
One axis, yes. So give one example. Either of axis, yeah, only one axis, yeah. Give an example. See, everyone can answer these things. It's not necessary that only one person will answer, or two or three. I want everyone to.
Sir,
Yeah.
car moving in a straight line or something moving in a straight line.
Straight path, yeah. Moving in straight line path. Or any other example? No example?
There you can consider a train on a straight track, no left and right, just
Okay,
straight.
that is kind of similar example.
Yeah.
Any other type of example? Upward 90 degree, yeah, correct. Or object or a stone thrown from a top of the building in straight path. So wherever there is a linear motion, that is one dimension motion. Linear, rectilinear, those are one dimension motion. And what will be two dimension motion? Two
On an
axis.
X and Y axis, or yeah,
Two axis. Yeah. So any example of for that? Projectile motion. Okay, yes. Or some, have you seen an insect crawling on the floor?
yes.
Yes.
He is also doing two dimension motion. Then what will be three dimension then?
So in the real world, how we interact up and down, left and right.
Sorry, what you're
with all
saying?
three dimensions.
Say again.
In the real world, how we interact with all three dimensions, X, Y, and Z axes.
Okay. Give one simpler, more example. Like
The astronaut in space.
which one? Which is?
The astronaut in the space. That's
Okay, astronaut in the space. Yeah. Okay, you have seen flying kite, right? It
Yes,
cannot be. It cannot be fixed in one direction because of air. So it is three dimension motion. It moves in anything random direction. Right? Okay. Those things, we'll discuss more about this in your next class. Any doubt in today's class?
No, sir.
No, sir.
Everyone? ठीक है. We'll go with detail about this topic one by one. One step. Okay. Everyone done writing? Shall I stop sharing?
Yes, sir.
ठीक है.